Good afternoon, everyone. My name is R.S.V. Mukhesh, and I'm going to explain about the linear regression technique and why it is used in this particular data, the Boston housing data, for predicting the house price of the data, and what are the steps and what are the roadmap or the pipeline which I've gone through so that I can achieve the desired result. The first thing we need to do the problem description of the given data. So as we know that you can see that there are required attributes like CRM, ZN, Indus, CAS. Like we know that each and every attribute can affect the price of the house. So in order to make sure that I've just I've created a data frame. As you know that uh, pandas is a module where we can use for reading CSV files and for reading Excel files. And also we can use it for creating a data frame as well. So in order, you can see the from like I've imported the Boston data from scikit-learn. There are, as we know, the scikit-learn consists of a lot of their data sets. So I've used the scikit-learn for loading the Boston data. And the key features are these attributes. So as we know that each and every aspect of an attribute can affect the price of the house. So the strategy that I've looked into is first we need to find the maximum correlation to the price, like find the attribute with maximum correlation to the price, and then we need to split the data into training and testing, and choose the required algorithm, either it is a linear regression or either it is some other algorithm. So depending upon the data that we choose, and we need to train the model, and we need to assign the model, and then we need to predict the price from the testing data. So like when it comes to data, like there are different types of data as we know that. So there are numerical data, categorical data, time series, unstructured, and everything. And what kind of data this Boston housing data is? It is in a continuous data. So let me give an example. The continuous data is something which where in a class there are like bunch of people, and we find heights of each and every person. So this is called a continuous data. And when it comes to categorical data, there are two types: nominal and ordinal. Or nominal is something. Let me give an example. So when we go through in a Google Sheets or Google Forms, like in order, like we need to fill up those Google Forms where we come across a few things where we need to choose yes or no or true or false, or we need to rate from 1 to 5, so in certain scale. That is called ordinal data. Whereas nominal data is we need to give our feelings, like in order in a way that in a programming lingo, like we need to give it the strings. We need to type those. It's not just giving from one point of scale to the other point of scale. And unstructured data, like unstructured data, that's common, the text, images, videos, and other kind of data. And like these are the data. And the data which we use here is an loading, or the Boston data is a continuous data. So we like now we have a data. So we have everything, the data, everything we have a data, and we use the pandas here. Like as I told before, the pandas are used for reading data frames or creating data frames or reading CSV files and as well. So in order, the pre-processing of data is like first we need to acquire data. So first we need to acquire data, and the we need to prepare data, and from the prepared data we need to give it as an input for the processing technique, and we'll be getting an output. So first thing, when I told the strategy of there are different kind of strategy. So the strategy that I followed is first we need to find the attribute with maximum correlation of the price. So in a machine language, machine learning lingo, the price or the target that we say it is a target, and others are the features. The attributes are the features. So in the correlation, there are two types, like the positive correlation and negative correlation. Like what is a correlation? Like in a statistical technique that can show whether and how the strategy of pays variables are related. So these are the things. And as you can see, so these are the different kinds of features are nothing but attributes of the from the data. So and here, as you can see that where the target, I've been concatenating the target to the required features. So whenever I find the correlation of these other 13 features, so which are the where the correlations are nearer to the price, so that would be the first strategy, the first step of finding, and finding the prediction will be natural. So that's what I've done. As you can see that I found like I've been finding a correlation, where the correlation, we have a function in the numpy. So the numpy is a bunch of mathematical functions, where we can find a mathematical functions in that module. So where you can see that, and apart from that, I would like to discuss about the defining error or something, mean square error, or we call it frequently, we call it as a loss function. um, so I just wanted the loss function that we used is a mean square error. Like most of you are familiar with the equation that is summation of I to 1 times of n uh, times of yi minus whole square, where y is the predicted value and yi is the truth value, or the true value, we say it as. And the purpose of why we use the mean square error is using numpy. Like we can make use of an vectorized operations. The like will be the function returns the mean square error value. So there are two ways, either we can create a function from the equation that we know, otherwise we can use a built-in function which is there in a numpy variable, so numpy module. So from that, where we can use that as well. And after that, after everything is let me sorry to delay this. Why do I use a linear regression? I just wanted to make sure that linear regression is something which is used for the supervised learning. The algorithm is used for, most of you have came through this linear regression technique, where this technique is used for the continuous data. And why it is used, because let me go through this plot. So you see here, this is called a linear regression line. So these are the data points which are scattered or in the plot. So this will be the predictor price, where we can show that owner or any people, it will be a minimum line. So we'll be finding a minimum line of from the given data. So from these points to these point, it will be a residual area or error value. So where in a line y is equal to mx plus c, where m is equal to the slope of a given line and c is the intercept of the y. So in order to minimize the given line, the dependent variables are the slope and the intercept. So so this method is, as I told you, this method is used when the output is continuous rather than the discrete. And that's it. I just want to make sure that, and everything is sure. Like I can't go through everything, every code that which I've written, because that makes a video or the topic which you go through it overwhelming. So I just want to make sure that given a brief idea about the techniques that which I used, and what is the reason behind, why is the reason behind, why are these techniques are used for these certain data, and that's it. Thank you.